So last day we took a look at the sine law, and it was useful in certain scenarios, namely when you know an angle, a side, and then another angle, or an angle, another angle, and then a side, or two sides and an angle in those orders. But there are two other scenarios. And for these, we're going to need a new law called the cosine law. So one of them is if you know two sides and the angle in between. And another is if we know all three sides and we have no angles at all. And again, for these, we're going to use a new law called the cosine law. So let's draw a picture and explain the law. So we again have a triangle A, B, and C, and again the opposite sides are A, B, and C. And the law states that if you take A squared and add B squared, and then subtract 2AB cosine of the C, you'll get C squared. And you can write it the other way around. I like it this way because it looks a little bit like A squared plus B squared equals C squared, which is Pythagoras. And we've seen that before, so there's just this extra piece to memorize when learning this one. And of course you could rearrange these letters, so if you change this instead of an A to a B and this to a C, then these also change to B and C, and this changes to an A, and that's what A squared would be. And you could have, instead of A and B or B and C, you could have A and C, and that would be A and C, and then this would be your B. So all three of these are considered the cosine law. Really, you only need to memorize one of them to know all three of them. Let's take a look and see how it works. So, for example, if I have a triangle, A, B, and C, and I know all the sides, 5, 9, and 8. So, we can start to solve this. Solving means finding all the angles and all the sides. All the sides are already there, so what we really need to do is just find one angle to get us started, and we can use the cosine law to find that. So let's try and get angle A here. Now, of our formulas up here, the one that includes angle A is this one. So if I have b squared plus c squared minus 2bc cosine angle A is a squared, and I substitute things in. So here's your A, here's your C, here's your B. This is our angle A that's already shaded. So start substituting them in. 5 squared, 2 times 8 times 5 cosine of A, and that equals a squared. And now to solve this, I need to get cosine A by itself. So let's just get a little more room. We can do that. So this is 64 and 25, and this is 80 cosine A equals 81. So I subtract 64 on both sides. I subtract 25 on both sides. I end up with minus 80 cosine A. These are multiplied, and I subtract and get minus 8, dividing both sides by negative 80 gives me 8 over 80, which is the same as 1/10 or 0.1. And now to find my actual answer, I have to do inverse cos. So cos to the little negative 1 like that, or second function cos on the calculator, and I'll calculate that I have 84.3 degrees. And the good news with the cosine law, there's no ambiguous case, and I have my solution. Now, to find the other angles, I could just do this exact same process, but solve instead, rearrange this original formula, and solve instead of cosine A, solve for cosine B, look above here and see which one involves cosine B, and then go through all the same steps. Alternately, and this is a little bit faster, I could now use the sine law to find the other angles. So I'm going to go and use the sine law. So sine A over A is equal to sine B over B is equal to sine C over C. And I know that I'm dealing with 84.3 degrees, and the opposite is 9. Let's just do the B. So sine B over, and B is 8. I multiply both sides, by 8, so I get 8 sine 84.3 over 9. That's what my sine B is. I calculate this, and I get sine B is equal to that ratio, and then I do inverse sine B, so this is the next calculation of that ratio, and get my angle, and you should check this, that you can actually do this on the calculator to get 62.2. And now I don't want to have to do all this work again. Once I know two of the angles, the third angle is easy to find by just doing 180, take away the other two. So I can use 180, take away A and take away B, and I can calculate that C is 33.6 degrees. And I could have calculated C using this ratio, C and A, in sine law, or I could have done C using the cosine law. There's lots of different ways to do the solving of these triangles. Let's take a look at one more example. So in this case, again, we're solving triangle ABC. We need to find all the missing sides and angles. And one way that you can tell that the cosine law will work is that we have side angle side. And so go ahead and work. Another way is you can try using the sine law, and you'll see that you don't have enough information to solve things. So I'm going to calculate this A value over here first, and so using the formulas, A squared is equal to B squared plus C squared minus 2BC cosine of A, and I just start putting numbers in. So B is 12 and C is 10, and the cosine and A is 40 degrees. I can do all of this on my calculator and get a solution. I got 60.1. Please pause the video and make sure you can do these sorts of things on the calculator, and I can take the square root and get this. A side is 7.8. Now to find another angle, because now I have all three sides, to find one of the other angles, we can use the cosine law or use the sine law. It doesn't really matter. Again, I kind of like the sine law, so sine A over A is sine B over B. Sine A is 40 degrees, A is the 7.8. I'd again use the storage button on my calculator and call it the actual letter A. B is what I'm calculating, and small b is 12. So again, I go through the steps, and so I multiply both sides by 12 to get my sine b by itself, and then I calculate what this is worth. In this case, it's 0.829, and I do inverse sine, and I get b is equal to 56.0 degrees. Let's just double check that, 56.0 degrees, and I can therefore just use 180 minus, and I can get 180 minus 56 minus the original 40 gives me 84.0 degrees. And we have completed the question.